Hello dear students, I am Ganga Bhosle, your statistics teacher. In this lecture, we are studying about measures of central tendency. There are 5 measures of central tendency that are commonly used. That is, first one is arithmetic mean or simply mean. Second, median. Third, mode. Fourth, geometric mean. And fifth is harmonic mean. Now we are studying about arithmetic mean or simply mean. Arithmetic mean is A dot m is the short form of arithmetic mean, and this arithmetic mean is denoted by x bar and is given by the formula sum of observations. In numerator there is sum of observations divided by, in denominator there is number of observations. Arithmetic mean is denoted by x bar and is given by the formula sum of observation divided by number of observations. There are some cases for arithmetic mean. First one, for arithmetic mean for individual observations or ungrouped data. Individual observations or ungrouped data. In this case, there are ungrouped data of n observations, that is x1, x2 up to xn on variable x. Then arithmetic mean, that is x bar is given by the formula x1 plus x2 plus up to xn, and for this data there are n observations, so divided by n, and this x1 plus x2 plus up to xn represented this x1 plus x2 up to xn represented in summation form summation xi, and I goes from 1 to n divided by, just a minute, summation xi divided by n. And for our simplicity or convenient, this summation, that is summation xi, I going from 1 to n, will be written as only summation xi. That is, arithmetic mean for individual observations or ungrouped data is given by the formula summation xi divided by n. Now we are see arithmetic mean, that is case number 2. Discrete frequency distribution. Discrete frequency distribution. Here in discrete frequency distribution there are some values of x1, x2 up to xn, and there are some frequencies related with this x1, x2 up to xn with frequencies f1, f2 up to fn. Then arithmetic mean for this, just a minute, sorry. x1, x2 up to xn with frequencies f1, f2 up to fn. Then formula of arithmetic mean for discrete frequency distribution is given by x bar is equal to, in numerator we have to calculate first product of f1 with x1, then add with product of f2 with x2 up to fn xn, divided by the summation of frequencies, that is f1, f2 up to fn. This sum is denoted in the summation form as summation fi xi I going from 1 to n divided by summation fi I going from 1 to n, and this sum is denoted by capital N. In numerator I is equal to 1 to n fi xi. This summation in denominator is denoted by capital N, where n is equal to summation fi I going from 1 to n. Then there is case number 3. Case number 3. For arithmetic mean for continuous frequency distribution. Continuous frequency distribution. Here in continuous frequency distribution we have to take out the class intervals, and from this class interval we have to put out the mid values of the class interval. The formula is same as arithmetic mean for discrete frequency distribution, that is x bar is equal to f1 x1 plus f2 x2 plus up to fn xn divided by f1 plus f2 up to fn, that is equal to fi xi I going from 1 to n divided by summation fi I going from 1 to n. And This sum is denoted by capital N. Summation Fi xi divided by capital N. Now, for arithmetic mean, there are some properties. Property number 1, that is, sum of observation is equal to the product of arithmetic mean and number of observation. That is, from this formula, x bar is equal to summation xi divided by n. We have, when we cross multiply these values, we get summation xi is equal to n x bar. That is, sum of observations is equal to the product of the arithmetic mean and the number of observation. The second property is the algebraic sum of deviations of observations taken from their arithmetic mean is 0. That is, summation of xi minus x bar is equal to 0. Then third property is the sum of squares of the deviations taken from arithmetic mean is minimum. That is, summation xi minus x bar bracket square is less than or equal to summation xi minus a bracket square. Then we see the point effect of change of origin and scale. The arithmetic mean is affected both by effect of change of origin and change of scale. That is, for this property, ui is equal to xi minus a divided by h, where a and h being constants. Then from this we write u bar is equal to x bar minus a divided by h. Okay. Then mean of combined groups. If x1 bar is the arithmetic mean of first group, that is, x1 bar is arithmetic mean of first group and with size of n1, and x2 bar is the arithmetic mean of second group of size n2. Then the combined mean xc bar is given by the formula n1 x1 bar plus n2 x2 bar divided by n1 plus n2. Okay. Now we solve examples of arithmetic mean. First one example is in SIM. This problem is on page number 12. Here in question, calculate the mean of intelligence quotients. Calculate the mean of intelligence quotients, that is IQs, of 10 students. Of 10 students are 80, 110, 120, 88, 95, 100, 105, 85, 102 and 112. Now solution of this exam. In this example, we have to calculate the mean of intelligent quotients of 10 students. Here there is 10 students IQs are given. First, we write the formula for mean. Mean, that is x bar, is equal to summation xi divided by n, which is equal to summation xi means we have to calculate their sum, that is 80 plus 110 plus 120 plus 88 plus 95 plus 100 plus 105 plus 85 plus 102 plus 112 divided by, there are 10 observations are given. So n, the value of n is 10. Calculate this sum, we get answer 997 divided by 10. When we divide 997 by 10, we get the answer 99.7. In your sim, the example, there are some printing mistake, so check this, then we solve example second. Example number 2. The following is the frequency distribution of the number of telephone calls received in 225 successive 1-minute intervals of an exchange. Obtain mean number of calls per minute. In this example, there are given number of calls with respect to their frequencies. Number of calls xi and their respective frequencies, that is fi. Number of calls are 0, their with respective frequency is 12, 0, 1, 2, 3, 4, 5, 6 and 7, 18, 21, 42, 45, 38, 35 and 40. Okay. For this example, we have to construct a table, that is solution of this. This is the problem of arithmetic mean of discrete frequency distribution. So here we have to use the formula x bar is equal to summation fi xi divided by summation fi. Okay, now we construct the table. Here in column number 1 we put out the value of xi, in column number 2 put out the values of frequencies, that is fi, and in column number 3 calculate the product of fi xi. 0, 1, 2, 3, 4, 5 and 6, 7. Okay. Their respective frequencies are 12, 18, 21, 42, 45, 38, 35 and 40. Then product of fi xi, that is 0 into 12 is 0, 1 into 18, 18, 2 into 21, that is 42. Calculate all these terms. So 180, 190, 210, 7 into 14 is 98. Here we write total of these fi, that is 12 plus 18 plus 21 plus 42 plus 45 plus 38 plus 35 plus 14, which is given by 225, that is capital N is equal to 225, and total of these fi xi is 864. Then put out these values, summation fi xi and n, that is this formula is written as summation fi xi divided by n, which is equal to the value of summation fi xi is 864 divided by capital N, that is 225. When we divide 864 by 225, we get the answer 3.84. This is our final answer. Now we solve next example. Third, calculate the arithmetic mean of the marks from the following. That is, there are given marks and their respective number of students. Okay. 0 to 10, their students are 12. 10 to 20, the students are 18. 20 to 30, the students are 27. For 30 to 40, 20. 40 to 50, 70, and for 50 to 60, there are 6 students. We solve this example by two methods. First one is direct method and second one is step deviation method. For direct method, we have to construct a table. First, direct method. First we construct a table, classes, midpoint, which is denoted by MP, that is xi, their respective frequencies fi, xi. Then here we have to calculate ui, which is equal to, and then fi ui. First we write the class 0 to 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, and last is 50 to 60. Then here in this column we have to calculate midpoint. How this is midpoint calculate? Here the lower limit is 0 and upper limit is 10. Add these two numbers, that is 0 plus 10 is equal to 10, and then divide this addition by 2, that is 10 divided by 2 is equal to 5. So we get the midpoint, that is xi is equal to 5. Same for this class, 10 plus 20 which is equal to 30, 30 divided by 2 which is equal to 50. For this class 20 to 30 we get the midpoint 25, then 35, 45, and last is 55. Their frequencies are, for the class 0 to 10 the frequency is 12. Write down here 12, 18, 27, 20, 17, 6. Then product of fi xi, that is 12 into 5 is 60. Then 15 into 18 is 270, 675, 700, 765, 330. Okay. Then how to calculate this ui? Ui is nothing but our ui is equal to xi minus a divided by h. Okay. Now the value of a, that is how to calculate this, the value of a. Here in column frequency, that is fi, we have to see the maximum number, that is 27, and this is nothing but our the value of a, and the value of h, that is difference between these classes, that is 20 minus 10 is 10, 30 minus 20 is 10, that is the value of h is 10 and the value of a is 25. In this frequency fi, the maximum number is 27, then the value of a is their respective xi, that is 25. So here we get ui is equal to xi minus 25 divided by 10. Here xi minus 25 divided by 10. For this class 0 to 10, the value of xi is equal to 5, that is 5 minus 25 is equal to minus 20. Minus 20 divided by 10, we get the answer is minus 2. Then the value of xi is 15. that is ui is equal to 15 minus 25 divided by 10, which is equal to 15 minus 25 is equal to minus 10. Minus 10 divided by 10, we get the answer minus 1. Same 0, 1, 2 and 3. Then product of fi and ui, that is we have to calculate the product of fi into ui. The value of fi is equal to 12 and their respective value of ui is minus 2. That is 12 into minus 2 is equal to minus 24. Then 18 into minus 1 is equal to minus 18. 0, 20, 34 and 18. Okay. Now we have to find out total. Here total. Summation of fi, that is 12 plus 18 plus 27 plus 20 plus 17 plus 6, which is equal to 100. Then summation of fi xi, that is 60 plus 270 plus 675 plus 700 plus 765 plus 330, we get the answer 2800. And fi ui, that is minus 24 plus minus 18 plus 0 plus 20 plus 34 plus 18, which is equal to 30. Okay. Now we write the formula x bar is equal to summation fi xi divided by n, that is summation fi. Summation fi xi, that is 2800 divided by f, that is summation fi, which is equal to 100. When we divide 2800 by 100, we get the answer 28. That is mean of marks of students are 28. Then we solve this example by step deviation method. Step deviation method. Okay. For this, we use the formula u bar is equal to summation fi xi divided by n, which is equal to summation fi xi, that is summation fi ui. In sim there is also a printing mistake. There is a summation fi xi. Okay. Now for u bar is equal to summation fi ui divided by n. The value of summation fi ui, that is summation is 30. 30 divided by 100, which is equal to 0.3. Where ui is equal to xi minus 25 divided by 10, which implies when we cross multiply these values, we get 10 ui is equal to xi minus 25, which is equal to, which implies xi is equal to 10 ui plus 25 implies is x bar is equal to 10 u bar plus 25 implies is x bar is equal to, put out the value of u bar, that is 0.3 in this equation, 0.3 plus 25. 10 into 0.3 is equal to 3, which is equal to 3 plus 25. 3 plus 25, which is equal to 28. Okay. So, the mean marks of students are 28. Now, we solve next example. The mean of marks in statistics of 100 students in a class are 75. The mean of marks of boys are 72, while their number was 60. Find out the mean of marks of girls in the class. This is problem number 4. This problem in SIM on page number 40. Okay. First, we write the given things, that is, here the mean of marks of boys are 72 while their number was 60, that is, the value of n1 is equal to 60 and their mean is given by, that is, x1 bar is equal to 72. Then in question they are given that 100 students, that is, (72) 100 students, that is, n1 plus n2 is equal to 100 and their mean is given by 75, that is, x bar is equal to 75. Here n1 is equal to 60 and the equation is given by n1 plus n2 is equal to 100. We put out the value of n1 in this equation, so we get the value of n2. Here n1 plus n2 is equal to 100. Therefore, the value of n1, that is 60 plus n2 is equal to 100. Therefore, n2 is equal to 100 when we put out the 60 in RHS, then it replaced by plus 60 by minus 60. 100 minus 60 is equal to 40. Okay. Now here we want to find x2 bar. So for this we use the formula x bar is equal to n1 x1 bar plus n2 x2 bar divided by n1 plus n2. Okay. Now put out the values of n1, n2, x bar, x1 bar in this equation, which therefore the value of x bar, that is 75, is equal to the value of n1 is equal to 60 into x1 bar, that is 72, plus n2, that is the value of n2 is 40 and we have to find out the value of x2 bar. Okay. divided by n1 plus n2, that is 100. Therefore, we cross multiply these numbers. 75 into 100, which is equal to 7500, is equal to 60 into 72, that is 4320 plus 40 x2 bar. Okay, 7500 minus 4320 divided by 40 is equal to x2 bar. When we calculate, we get the value of x2 bar is nothing but 79.5. That is, mean marks of girls are 79.5. Therefore, mean marks of girls are 79.5. Okay, I hope all of you understood arithmetic mean. There are some cases, properties and examples. Okay, thank you.